In this video, I'm going to provide the solution to the Integral Online Test T2, question 9. So we're asked to solve the equation cosine x equals 6x, but we are told we are going to use the small angle approximations. So we know that cosine x by our small angle approximations is approximately equal to 1 subtract a half x squared. So making this substitution into our original equation, we get 1 minus a half x squared is approximately equal to 6x. Well, that is just a quadratic equation, and we can collect all the terms on one side. I'm going to collect them on the right-hand side. So we get 0 is approximately equal to a half x squared plus 6x. Subtract 1. And you can just solve that quadratic equation as it is on your calculator if you want to. I'm going to use the quadratic formula. Firstly, I'm going to multiply it 3 by 2 just to make my life a little bit easier. So we get 0 is approximately equal to x squared plus 12x. Subtract 2. So we know x is approximately equal to, well, minus b, so minus 12, plus or minus the square root of b squared, so 12 squared, minus 4 times a, which is 1, times c, which is negative 2, all divided by 2a, so all divided by 2. And doing a bit of simplifying, this ends up being x is approximately equal to minus 12 plus or minus the square root of 152 all over 2, and we can see that 152 is divisible by 4. In particular, 152 divided by 4 is equal to 38. So this is equal to negative 12 plus or minus the square root of 2 root 38 all over 2, which is equal to negative 6 plus or minus the square root of 38. Okay, but in the question it asks for the smallest positive root, so the x that we are in particularly looking for is that x is approximately equal to negative 6 plus the square root of 38, and giving that to three significant figures just by using your calculator, we will see that this is approximately 0.164 to three significant figures. And notice that this is small, and that is important because we know the small angle approximations are valid when x is small only. So if you start getting a big number here, then you know something has gone wrong. And if we sketch the graphs of y equals cos x and y equals 6x on the same axis, we will get something that looks a little bit like this. So this is y equals cosine x, and y equals 6x is a straight line with a gradient of 6. And so the x value that we have found is the intersection of these two curves, because that is the solution to the equation cos x equals 6x. So it is the x value here, and we can see that that is a reasonably small x value that is quite close to 0, and we have shown here that that x value is approximately 0.164 radians. And I've used some graphing software to show how close this approximation actually is. So we can see that y equals 6x is the blue line, y equals cos x is the green line, and y equals 1 minus a half x squared, so our approximation of cos x is the red line. And we can see that the blue line intersects the red line at x is equal to approximately 0.164, and that is the solution we have found, and that's the equation we have solved. However, we can see that for very small values of x, and when x is approximately 0.164, the red line and the green line, so cos x and our approximation of cos x, are very similar. So in fact, x equals 0.164 is an approximate solution to the original equation.